All right, welcome back, everyone. Week 2 of quarter 3. And last week we talked about solving a system of equations using graphing. This week we are going to look at the second method, and that method is called substitution. And to give you an idea of what substitution is all about, let's take a look at this money that's down here. So it shows a couple of different ways that you can take $1 and turn it into something made out of coins, right? So if you look at the first example, there's $1 bill, and it's equal to 2 quarters and 5 dimes in the first, or sorry, 10 nickels in the first example. And then in the second one, the $1 is broken down into 8 dimes and 20 pennies. Okay, and if we just take a look at that information right there, what can we deduce about these two stacks of coins? Number one is they're made up of different coins, right? But the important thing is that on the left-hand side, we have 2 quarters and 10 nickels, which is $1, right? And on the right-hand side, we have 8 dimes and 20 pennies, which adds up to $1. So the thing that we can deduce is that these two stacks of coins are equal. So you could substitute one stack of coins for the other and still have $1. Okay, so that's kind of the concept of what we're going to talk about today with substitution. So the way substitution works is if we look at this example here, now instead of having a graph, we have 2 equations, and we're going to have to do something algebraically to figure out what x and y are instead of just looking at a graph. If we had a graph, we could easily graph these, although these would be a little challenging to graph because of that 80 and that 20. We'd have to have a graph that's pretty good size. But the thing to notice is this kind of like that dollar bill example up above. If you imagine that y is a dollar bill, we have y here, and it's equal to some amount right here. We don't know what that amount is. We know it's 4x plus 80. So you could imagine that we have $1 that's highlighted red is equal to some number of coins highlighted green, right? But then what we could notice is that, hey, I've got another dollar down here, and it is equal to a different set of coins down here that's represented by 7x plus 20. Okay, so if we think about up above, those 2 sets of coins, even though they were different coins, they were still equal to each other. So that's kind of the thing that we're going to do here is we're going to say, hey, I know that y and y are the same thing, kind of like the dollars up above. And then that means that the 2 things that are highlighted in green are equal to each other. So all we have to do if we see 2 equations where it's y equals and y equals, all we have to do is set those 2 things equal to each other. So we have 4x plus 80 equals 7x plus 20. Okay, so now we have to go back to first quarter when we did some solving equation with variables on both sides and just solve this for x now. Okay, so if we remember when we solve for x, we always want to move the x's first. And in this case, we move the smaller one. So the 4 is smaller than 7. So I'm going to subtract 4x. I'm subtracting it because it's already positive. So that just cancels itself out on the left-hand side. So we have 80 equals 3x plus 20. Okay, now I want to get the x by itself. So I have to start by moving the 20. So since it's plus 20, I'm going to subtract it. So 80 minus 20 is 60. Just bring down the 3x, and the 20s just cancel each other out. And then the final step is we just have to divide by 3, and we get 20 on the left-hand side and x on the right-hand side. So x is equal to 20. Okay, so once we find x, all we have to do to find y is go back up to one of our original equations, and it doesn't matter which one, and we just have to plug that 20 in for x to figure out what y is. So I'm just going to pick the top one, y equals 4x plus 80. And I'm going to replace the x with the 20. So we have y equals 4 times 20 plus 80. 4 times 20 is 80, so we have 80 plus 80. So y is equal to 160. Okay, so if you remember though, anytime we have a system of equations, we want to write the answer as a point. And so the point here is the x value and the y value. So the value is 20 and 160. So we can write it as 20, 160, and put a box around it. Okay, now the nice thing about systems of equations is we can check our work to show that we have the right answer. So all we have to do is take each one of the equations and plug in our two x and y values. Okay, so we have the first one is y equals 4x plus 80. And if I plug in my x and y values, I'm going to have 160 equals 4 times 20 plus 80. And we kind of already did this one, so we should be confident that this one's right, but we should check it anyway. So this is 80 plus 80. So 160 equals 160. Okay, so that checks off. That one works. And then I'm going to do the same thing with y equals 7x plus 20. Plug in the 160 for y and the 20 for x. And so 160 equals 140 plus 20. So 160 equals 160. And that one checks off. So we know that our answer is correct. All right, let's do another one. And then you guys get to do, it looks like, just 2 on your own. All right, so here we go. Remember, y and y are equal to each other. So we have y and y. It's kind of like those dollar bills, remember? And that means that the two things that they are equal to each other. So those two things are equal to each other. Okay, so we can write this as negative 5x plus 16 equals negative 3x plus 24. Okay, so with the negatives, they're a little bit tricky to figure out which one is the smaller x, but remember, negative numbers as they get bigger are actually smaller. So negative 5 is smaller than negative 3, so we're going to add 5x to both sides. So when we do, it cancels the 5x. So we have 16 equals negative 3 plus 5. So negative 3 plus 5 is going to be a positive 2x. Okay, and then 2 steps to finish this one. Subtract 24. So we have negative 8 equals 2x because the 24s cancel each other out. And then we divide by 2 to get x equals negative 4. Okay, so it's okay to have negatives. If you remember from graphing, we had answers that were negative, so it's okay. All right, and then we can just pick one of these. It doesn't matter which one. They both have a negative. Sometimes I look at it and try to avoid negatives, and sometimes I try to avoid big numbers, but let's just do the first one again. You don't have to always do the first one. You can do the second one if you want, but so we have y equals negative 5x plus 16. And then I'm going to plug in that negative 4 for x. Whoops, I put it in the wrong spot. Don't want to do that. Negative 5 times negative 4 plus 16. So two negatives, when multiplied together, become positive. So we end up with y is equal to 36. Okay, so our answer that we think is the right answer is negative 4 and 36. But just like the other one, we're going to check our work. So I'm going to write both of these equations down while I can. And then we have y equals negative 3x plus 24. And then I'm just going to go and plug in the x and the y to see if I got the right answer. So we have 36 equals negative 5. This is the one we just did. So again, hopefully we know what we're doing. So if we simplify this, this is 20. So 36 equals 36. And we can check that off. All right, next one. 36 goes where y is. Negative 4 goes where x is. Notice how when I plug those in, I use parentheses. If you don't use parentheses here, it might look like you're subtracting, and you don't want to do that. Okay, 2 negatives again, make a positive 12. So 36 equals 36. And we can check that off. So we know that our negative 4, 36 is a good answer. All right, you have 2 to do on your own. And remember, when you're done with these 2, you're going to enter them into Schoology. And if you have any questions, please let me know.